And now, ladies and gentlemen, it's time to present the grand prize winners in this year's competition. Those components that, in the eyes of this year's judges, have most successfully met the criteria for excellence of design in a powder metallurgy component. In the automotive engine category, PMG Fusen GmbH Germany and its customer Schaeffler Group Automotive have won the grand prize for a stator used in a VVT system exhaust operating in a 1.4-liter engine. Made from a modified iron-copper PM material, the complex part is formed to a density of 7.0 grams per cubic centimeter. The stator, featuring 5 complex center holes, is an integrated one-piece design for the belt pulley and VVT housing. Very tight tolerances help to minimize any internal oil leakage between the adjoining pressurized chambers. The PM stator helps reduce fuel consumption and the formation of exhaust gases, as well as improving engine performance, especially torque at low RPMs. Burgess Norton Manufacturing Company and its customer Means Industries have won the grand prize in the automotive transmission category for a notch backing plate and a pocket plate used in a mechanical diode one-way clutch for a 6-speed automatic transmission. Made from sinter-hardened PM steel, the notch backing plate weighs 1.85 pounds and the pocket plate 2.54 pounds. The PM plates are assembled with steel struts, coil springs, and a snap ring, thus forming the one-way clutch. Both parts are made to a density of 6.7 grams per cubic centimeter. The notch backing plate has a tensile strength of 75,000 psi, while the pocket plate has a tensile strength of 90,000 psi. PM provided superior precision and a 70% cost savings over wrought steel parts. The annual production estimate for the two parts is more than 2.5 million pieces, accounting for almost 8 million pounds of iron powder. Mitsubishi Materials PMG Corporation, Japan, and its customer, Fuji Kiko Company Limited, have won the grand prize in the automotive chassis category for a high-strength gear set used in a new tilting and telescoping steering column. The gear set consists of a tooth lock and 2 cams. Made from diffusion alloyed PM steel, the parts have a density greater than 7.05 grams per cubic centimeter and a tensile strength greater than 159,000 psi. The parts are made to a net shape and replaced conventionally forged and machined parts. Capstan Atlantic has captured the grand prize in the hardware appliances category for a PM steel gear set used in a high-volume business machine printer. The gear is roll densified to a surface density of 7.8 grams per cubic centimeter. The gear has an AGMA Q10 precision level and the pinion an AGMA Q8 level. The core density of both gear and pinion is 7.3 grams per cubic centimeter. The gear tooth surface fatigue resistance equals that of a wrought steel 8620 carburized gear. The part, which has opposing helix angles, is formed to a net shape, except for hard-turning the datum journals. Single press, the PM gear replaced 2 machined gears at a cost savings of more than 40%. Our final grand prize for 2008 in the medical dental category goes to Parmatech Corporation for a 17.4 pH stainless steel articulation gear used in a surgical stapling unit. Made by metal injection molding to a density of more than 7.65 grams per cubic centimeter, the MIM part has an ultimate tensile strength of 130,000 psi, a yield strength of 106,000 psi, and an HRC 25 hardness. The complex MIM design, which has tight tolerances, is formed to a net shape and requires no secondary operations. The MIM design provided a 70% cost savings compared to machining the gear from bar stock. Ladies and gentlemen, those are the grand prize winners in the 2008 PM Design Excellence Awards competition. Please join with us in welcoming our winners to the stage as we invite them to receive their awards.